Hello everyone, welcome back to my channel Tech Explain Simplified by Arojit. My name is Arojit Datta. On last video we discussed about SDWAN architecture, different components of SDWAN and different types of planes and the SDWAN architecture. So today we'll start with the difference of control plane and data plane, and then we'll go further. So chalo, let's start. Okay, so on this slide we'll discuss about the difference of control plane and data plane. So what control plane does, so before going into the details we'll just see the picture here. As you can see, the left hand side, these are the data plane or the edge devices where data planes works, and the right hand side we have the SD-WAN parts, which is the main brain and act as a control plane. Okay, so in control plane, what it does, it focus on the routing logic, centralize the network control. It builds a routing table based on the protocol that is running. So it could be either ISIS or OSPF or BGP. Okay, it defines different policies. So for example, it could be defined security policies in a different way or normal traffic in a different way, and that's how the traffic should flow from the edge devices till the destination. Okay, and it's mainly work on the centralized part, so we also called as an orchestrator. So it making the enterprise wide decision taking capabilities and sharing them with all the relevant nodes at the edge side. Okay, it handles the network management tasks like device setup, key management, topology creation, etc. Now let's see the data plane. In data plane, it's mainly responsible for forwarding packets between source and destination based on the path or logic that been created by the control plane, which we have already checked earlier. That control plane prepare that path. Okay, and it execute the instructions set by the control plane for real-time traffic flow. So control plane will already prepare the path, and data plane will just follow that path to flow that to send the traffic based on their availability or based on their policies. So that will be done by data plane. They will just flow the path. Okay, and it will be created by control plane. So these are the first main difference. So, and how it will work, it will select the best available path which has low latency, which has dedicated, if there is any dedicated path being created for security policies or like that, so that only they will follow. Okay, and it means, so data planes are mostly on the edge devices, so its main moving users and business traffic is the main part, just following the control plane policies. Okay, so this is mostly the difference between control plane and data plane. So on this slide, I have mainly mentioned the same points which we have already discussed on the last slide. So what control plane's main function is to routing policies, making the routing policies and making the decision of the traffic flow. Then where it locate, it's on the central controller or the orchestrator. Then what are the protocols it work? It could be BGP, OSPF, ISIS. The main role is to decision maker. So it decides that what are the things data plane needs to follow, and the example is routing table creation. Okay, then in data plane, in main function is packet forwarding. Where it works, it's on the edge devices. So protocol IP forwarding. Okay, the role is what are the decisions control plane are making, they need to follow it, so they need to implement it. Okay, and example is moving traffic through the dedicated path or the path that been created by control plane. Okay, so these are the basic difference. Okay, so now we will see the difference between overlay network and an underlay network. So as you can see here, left hand side we have that typical underlay network connectivity. So where we have normal routers connected and it's CE and PE, and we have that fiber connectivity with that. Okay, and over that we are running MPLS or BGP. And in the overlay section, what they are doing, so rather at the CE side we are having that SD-WAN edge devices or that SD-WAN edge connections, and they are just creating like a tunnel to control with the controller. So it's making a overlay section along over the same underlay part. Okay, so here as you can see, blue is for underlay and red is for overlay. Okay, so what it actually does, as I mentioned already here, that underlay network is a physical network. It's responsible for delivery of packets over DWM or MPLS, internet, etc. But while an overlay is a logical network that use network virtualization to build a connectivity on top of physical infrastructure using a tunneling encapsulation such as VXLAN or IPsec. Okay. Now the thing is why it's needed and why it's most important. So as we are aware that internet is now everywhere. We can access it's much better from the previous scenarios or a couple of years back. Okay, but internet is not 100% secure. Okay, that means that whenever you are using your Wi-Fi, it can be hacked easily until unless you are running a IPsec or some kind of VPN connectivity. It's not secure enough. So whenever we are going for a VPN, it comes under the overlay part. Okay, and that also it's a extra work or extra charge you need to pay as a customer for that, and the configuration also takes some time, extra time, not like initially when you are configuring the MPLS network. At the same time you can configure it, so it will take extra time. The customer need to pay for that. Okay, so this is the main concept. Now the transport dependency also is there. So assume that internet is secure. We have somehow read that with the IPsec and all, but the customer wants to divide the application between different path. Like YouTube will be on a 4G, cloud-based application over broadband, and other services like email or their company related, their enterprise customer related traffic will be over MPLS. So for that also it will take different configuration on different path, and it will take a more static configuration type of things. It will take more time. All these things will be happen. Okay, so to overcome all these things, SD-WAN is there. Okay, and SD-WAN is covering all these things. We can discuss about another concern or another issue as well. So like if customer wants to load balance by combining their underlays of different traffic. Okay, so they want to load balance via broadband and 4G and MPLS as well. So it will be, again, it's a very difficult to do, and it will take much more time. So overlay can overcome all these type of problems which we are normally facing in underlays. Okay, and overlay is what mainly overlay network or the SD-WAN is doing. It's a mainly software based, so it's not directly dependent on any kind of transport. So you can use any transport path, but over that we can run SD-WAN. Okay, and so on that, what is the most important thing is, like, once you have configured or you have installed the underlay section, it's done. You don't have to think about it further. Okay, so rest of the work will be done by SD-WAN. So this is the main difference that we have between overlay and underlay network. So let's jump into the next slide. Okay, so now on this slide we'll see how this overlay network is getting formed over the underlay. So in this picture as well, you can see this is the MPLS underlay path that we have, and over that there is a tunnel or overlay path is getting created. Okay, and these are the edge devices. Okay, we have, so one is at one location, another location, and how its overall connectivity is working we'll discuss here. Okay, so we can, and we'll use this following example for that. So on this example we can see the JRE tunnel is formed by the SD-WAN edge devices. Okay, and the edge device adds a JRE tunnel header with a new IP header and a mask in an inner IP header form that MPLS domain forward to the outer IP header. So this is what they are adding here. Okay, and once that package reaches to the destination, the SD1 watch SD1 edge device remove that outer IP header and the tunnel header, and what we get is the original IP. So while sending, they are adding it here, and at the destination side before going to edge, it's removing here. Okay. So during all this process, the overlay is not aware of the underlay part. So whenever all these things are going, they are not bothering about what are the things they are connected here, which type of cabling is there. They don't care about it. Okay. The same process can be done for the internet underlay as well, but with the additional encryption will be needed for like VPN or IPsec. Okay. And all this can be done seamlessly using the same SD1 H box. Okay. So the overlay is formed, and once encapsulation happen at the left SD1 box, when the header is moved at the destination. So we are adding it here, and the encapsulation started from here, and then it's getting delete here. Okay. Next, what we have, that how it's solving the things. So first thing is security issues solved. So earlier we need to install VPN or IPsec separately, but in this case SD1 is providing the same tunneling concept in the first installation itself, so it's by default is present. Okay. Then transport path independence. So the same SD1 overlay can seamlessly connect to multiple different media like internet, MPLS or L2 media as well, and the overlay doesn't need to care about the transparent media. Okay, while it's using the tunnel. So when it's going via a tunnel, no matter what are the paths are available here, they don't need to think about it. Okay. And then we have the considering of overlay as a transport. So that means there is no limit on the number of multipaths that can be used in overlay to carry the traffic from source to destination, and that also helps them for load balancing. So that is very scalable comparatively our old traditional network or old traditional underlay section. So all these points, it wins the overlay section over the underlay part. Okay. So I'm completing the part 2 here, because on part 3 we will have some more important things like OMP, then the vSmart, vBond, vEdge and orchestra details. So these are the things, it will take more time. So I'll cover all these 3 topics together, and that will be the last for the SDWAN architecture in detail. So it's a 3-part that I have prepared. So thank you all, thank you for watching my video, and stay tuned for the upcoming videos, and as well share your feedbacks with me, whatever you like, whatever you don't like. I will try to fix those things. Thank you again. Chalo, bye.